Welcome to part 2 of the recursive rules for sequences. Say hello to my 7th hour class. That was 7th hour. They're really smart and they understand all these examples already. So what we're going to do is just 3 examples. We're going to start with this one. Write an explicit and a recursive formula for the arithmetic sequence where a sub 1 is equal to negative 5 and d is equal to 7. So the recursive rule means that I need to have a term before I can find the next term. So my first term is already given, which is negative 5. If my common difference is 7, what I need to do is add 7 to get the next term. So my next term obviously would be 2 then, because negative 5 plus 7 would be 2. But what I'm trying to find is my nth term. And to find my nth term, I need to take the term that came right before that, which is my a sub n minus 1, and I need to add 7. So this is my recursive formula. The explicit formula is found by using the formula that we have for an arithmetic sequence. So the term in an arithmetic sequence is a sub n is equal to a sub 1 plus n minus 1 times d. A sub n is equal to a sub 1 is negative 5 plus n minus 1 times 7. And now all I need to do is simplify this. So negative 5 plus 7n minus 7 and add my like terms. And this would be my explicit formula for this problem. Now we're going to find an explicit and recursive formula for a geometric sequence. They give us a sub 1 is negative 2 and the common ratio is 2. So the recursive rule would be given by a sub 1 is equal to negative 2. I always have to start with what a sub 1 is equal to. And then to find a sub n, I need to have a sub n minus 1, which was the term that came right before it, and multiply it by 2. So if I wanted to find the 230th term, I would have to find the 229 terms that came before that. The explicit rule we're going to find by using the formula. And remember, with the geometric sequence, a sub n is equal to a sub 1 times r raised to the n minus 1. So all I need to do is substitute. Oops, that's a positive 2. Substitute and then simplify. So negative 2 times 2 to the n times 2 to the negative 1. And remember, the way that I can get this, how I can break this apart, is because when I multiply with the same base, I add exponents. And now I can simplify a little bit. This negative 1 as an exponent is the reciprocal, so that would be 1/2. 1/2 times negative 2 is negative 1. So my explicit formula is a sub n is equal to negative 1 times 2 raised to the nth power. And finally we come to the last example. This example is the same problem as example 4 on page 682 of your book. And we need to write a recursive formula for the sequence 1, 2, 2, 4, 8, 32, and so on. Now, all recursive formulas don't have to start with just a sub 1 and then go straight to a sub n. Sometimes you have to define a couple of the terms first in your recursive formula. In this case, that's what I'm going to have to do. If you notice this 2, the second 2 here, that's the same thing as 1 times 2. So it was the 2 terms that came before it. This 4 is 2 times 2. So it's the 2 terms that came before that. I multiply those together. The 8 is 2 times 4, which again are the 2 terms that came just before the 8. And 32 is 4 times 8. the two terms that came before that. So a sub 1 is given, a sub 2 is also given, and now I can find any term as long as I know the first two that came before it. So a sub n is going to be equal to the term that came just before that, which is a sub n minus 1, times the term that came just before that, which is a sub n minus 2. So this is my recursive formula for that sequence.